Now we'll go through the solutions for A4, and we're dealing with centers and measures of center. The following is a histogram showing the actual frequency of the closing price of a particular stock on the New York Stock Exchange over a 30-day period. Without doing any calculations, compare the values of the mean and the median. Well, I can probably tell it looks like the data is being pulled to the right. And actually, let me go ahead and get my little laser pointer so I can make sure I have it. There we go. Sorry, guys. So it looks like it's being skewed to the right. So if I've had the data in a clump, it's being stretched out to the right, which means that the mean is drawn to the right of the median. So the mean is larger than the median because the histogram is skewed to the right. The first answer is the correct answer. So we didn't have too many of you struggle with question 1. Question 2, some of you thought the median was a number in the middle, so how's the answer 38? Shouldn't it be 15? So you can see several of you were struggling with it, so let's go ahead and talk about this. So we have a total in a random sample of 159 sandwiches currently sold at fast food franchises. The fat content grams results are in the histogram below. Which of the following could be the median fat content? So the median is the halfway point. There are 159 sandwiches, so the halfway point would be 79.5. In other words, it's between 79 and 80. So if I count up to 78, so right here, if I do the first few bins, I've got 8, I've got 7, 10, 15, 15, 23. That adds up to 78. So that means the 79th and 80th points have to be in this next bin. So that is the bin with 28 points, which means the median is somewhere between 35 and 40. Now, it can't be all the way to 40 because remember that the left boundary on a bin, that means 40s are actually over here. But it could be exactly 35. We don't know. So it's anywhere from 35 to almost 40. And that makes sense. So 38 is a possible answer. Question 4. I'm struggling on calculating the standard deviation and how to relatively compare the standard deviation between two sets of stats. So let's go ahead and take a look at this one. There are 10 students in Mrs. Thomas's afternoon stats class. The maximum point total for the most recent quarter was 200 points. The point totals for the 10 students are given in the STEM plot. All right, so these are starting at STEM 11. So 116 is 116 points, 118 is 118 points. Now, the mean score is 134.4 points, and the standard deviation is 18.64 points. If the score of 179 was supposed to be 129, how would the value, the mean, and the standard deviation change? So the important part here, it's not really that you have to actually calculate it. You have to think, okay, if this 179 was really 129, then the width would be less, right? Less spread, and also this is skewing the mean high, so the mean would be less if it was really 129. But we have data, so let's go ahead and plot it and see what happens. So with 179, you can see there's a little bit of skew. It's hard to see because of this histogram. And there's your mean and your standard deviation. Your mean is 134.4. Standard deviation is 186. Now, if we change that 179 to a 129, the mean goes down, like I indicated, and your standard deviation goes down because you have less spread. So, the graph is skewed right, so the mean is greater than the median. The standard deviation is high because the spread is high. If we remove the outlier, the mean would decrease, and the spread lowers, so the standard deviation would decrease. Oh, sorry, and I should probably say the answer is the mean decreases and the standard deviation decreases. Answer B. Question 5, how do we find a median of a data set? So let's go ahead and look at this one. You don't have to calculate the exact mean and median. So we know it is skewed left, so the mean is less than the median. So the mean is either at 1 or 2. It can't be at 3. Now 2 makes more sense, but the median is trickier. We don't know. We know it's either at 2 or 3. We just don't know which one. So we're going to stack the areas above 0.1. All right, so I'm going to take all this area and move it over here. All right. This is just to help me get an idea on symmetry. And you can see once I do that, if this data was not here, the midway point would be smack dab in the middle. But we have a few extra data points, so the smack dab in the middle has to fall in column 3. So if the median's in column 3, that means the mean is either 2 or 1. So it could be B and it could be D, right? So 2 is too low for the median. We know it's 3, and it's consistent with our thinking that the mean is actually 2. So if you recall, let's go back. Oops, sorry. The mean is either 1 or 2. 2 makes more sense just based on the distribution of data. And then just to double check the median, you can see, that the median has to be in this column. So the answer is D. Question 6, trying to decide between the answer choices. All right, so what I'm going to do is I'm going to calculate for each of the answer choices, A, B, C, D, or E. So what are we looking at? A study of music preferences of 100 randomly selected male students in each of the 3 geographic locations resulted in the table below. Which of the following is not a true statement? So I'm going to kind of write true and false for every statement. And we'll see which one is false. So if he prefers classical, which means it's the top row, it is more likely he is from the west than from the south. And you can see that's true. We have 20 from the west and only 10 from the south. And I can actually calculate proportions or probabilities, and it's 1/3 and 1/6. So this is actually true. So it's not our answer. B, if he is from the northeast, which is this column, then it is more likely he likes classical than country. And even without doing math, I can see that classical is higher than country. This statement is also true. If he is more likely to be from the northeast than to like country. So here I need to calculate the northeast. So the total for the northeast is 100 out of 300, which is 1/3. The total for people who like country is 120 out of 300. And when you simplify, that's 2/5. And you can see that country, or northeast, is actually less than country. This is like 0.4, this is like 0.33. So statement C is false and is most likely our answer. Let's double check the others. If he prefers country, then it is just as likely he is from the south or not from the south. That one's actually true. You have 60 in the south and you have 60 not in the south. Then finally E, if he is from the west, hopefully that'll work. Given that he is from the west, it is just as likely he prefers country or prefers pop rock. Okay, so we got country. We know he's from the west, right? So the west, there are a total of 100. So which ones like country? They're 40 out of the west, 40 out of 100. For pop rock, that's also 40 out of 100. So that is true. An office supply catalog gives a description of bookshelves that includes the following variables. Which of these variables is categorical? Well, you got the width of a bookshelf in inches. Well, width is quantitative, and it's number of inches. Width of a bookshelf in feet. Same story. Now we just change it to feet. Height of a bookshelf in inches. Okay, so it's still quantitative. It's the number of inches. Weight is also quantitative. It's number of pounds or kilograms, depending on how you're measuring it. Color is categorical, so it could be black or it could be brown or it could be any other color. It's not a number, so the correct answer is E. Finally, question 8. Question 8 says the pie chart describes the distribution of favorite school subject for the 300 high school students. How many students reported that math is their favorite subject? So we know 26% of the 300 reported math as their favorite subject. All right. Then we just take that to 0.26 and multiply it by 300, and we get 78. 78 is the correct answer. Remember to share any questions you still have after I went through these problems.